Welcome, 8th graders. You are on day 4 of the Automation and Coding Design Notebook. And so at this point, you should have learned a little bit about complex, simple, and basic behaviors. And now we're going to take that and go a little bit further. We're going to take it a step further in writing pseudocode by breaking down complex tasks into simple and basic behaviors. And that's what your homework is for today. That's what I'm going to show you for this video how to do. So we're going to scroll down until you get to creating the solution. And for creating the solution, we have a bunch of complex behaviors in this column, simple behaviors that we're going to have to break down here, and then basic behaviors that we will break down here. And so our activity here is for each of the complex behaviors listed, break down each one into simple behaviors where we use and, commas, periods, and then we break that down into basic behaviors, which is individual actions. And so I've written down common codes that we're going to use for basic behaviors into this column over here. And we'll go through one together where we just we'll start with the third task here. And we're going to start with the complex behavior. And from here, we have an entire overall task. And it says a bump switch starts both motors spinning in the same direction at a fourth speed for 5 seconds and then stops for 2 seconds. After stopping, the motors will start again in the reverse direction for 5 seconds full speed and then stops. So that's the overall task. First thing we need to do is take this complex behavior, this overall task, and break it down into simple behaviors. And so you can see the first two are almost done for you, where the first part it says a bump switch is pushed. So basically, we're going to just break down this entire thing in chunks. So the first thing it says, a bump switch, that's what we're using, and nothing's going to happen until we hit that bump switch. And that's what this is listed over here. A bump switch is pushed. Once a bump switch is pushed, what happens? Well, it starts both motors spinning in the same direction at a fourth speed for 5 seconds. That's my next step. So I'm basically going to take that information and type it in here, where it's going to be motors turn for a quarter speed for 5 seconds. Okay, so I've done that, and then it stops for 2 seconds. So that's the next part here from the complex behavior that we're, again, breaking it down into steps. And so the next step then is stopping the motor for 2 seconds. I'm going to just write stop the motors. After the motors stop, right here it says the motors will start again in reverse direction for 5 seconds at full speed. We'll eventually get to the last part. That's a separate step, but this step right here I'm going to write in for step number 4. So it says start again in the reverse direction for 5 seconds. Start motors in reverse direction for 5 seconds at full speed. Okay? Once we do that, the final step is they stop. The motors stop at the end. Motors, stop motors. So we have 5 steps here that we as humans can understand, and then when we break it down into individual actions for basic behaviors, we have to write it in a way that a computer will understand it. And so we're going to take each one of these and break it down into an individual action using one of these basic behaviors or common codes that a computer understands. So for the bump switch is pushed, which one of these will indicate that a bump switch is being pushed to trigger the rest of the computer code? So I can see this one here where it says use this code for bump switch. I'm going to just copy this entire thing until which sensor, and what's written in blue is what needs to be replaced. So for example, I would say either left motor, right motor, what speed, but I will replace that. Everything that's written in red can remain the same. And so which sensor am I pushing? I'm going to write bump switch. Then I'm going to my next behavior, which it says motors turn a quarter speed for 5 seconds. And so I got to look at which code over here will make that happen. Which one is going to make the motor start? Well, at the very top it says start motor, and again I have to replace what's written in blue. What motor am I starting, and what speed is it going to be at? So I'm going to copy this, replace it, and replace the blue with the motor that I'm doing. And remember, I can't just say both motors. I'm going to do a separate code for that. So which motor am I starting? I'm going to say left motor. And what speed am I doing? Well, it indicated we're doing it at a quarter speed. So if the maximum speed is 127, well, what's a quarter of that? You might have to use your math there, and I'm just going to tell you right now. 120, I got to do the math in my head real quick. 63. We're going to say 32 is a quarter speed. And I'm just doing that to avoid decimals for right now. And so since I'm doing both motors turning at that direction or at that speed, I'm going to take that same thing, but instead of having it being left, I'm going to say the right motor. So far I have until the bump switch, I start the motors at a quarter speed. Well, how long am I doing that for? Well, it says for 5 seconds, so I need to go over here to indicate how long am I doing it for. I'm taking this code right here, copying it, Control V, and how long is it for? 5. I don't need to write seconds. The computer knows it's already in seconds, so I just write 5. So far, I've completed the first 2 over here where I've hit the bump switch, the motors start at quarter speed for 5 seconds, and then the next one is stop motors. So I can see from over here which one is going to make that happen. I do this one here, Control C, stop motor, and again, I can't do both motors in one code. I'm going to do stop motor left and stop motor right. All right, so I now have the first 3 steps here written in basic behaviors. So I've, excuse me, I'm going to continue going through this. I have 2 more to go. Start motors in reverse direction for 5 seconds at full speed. Start motors in reverse direction. So which code over here is going to indicate that I'm starting the motors? Of course, it's the start motor. Which motor am I starting? Well, it said, well, we're doing both of them, so I'm going to start with the left motor in reverse direction. So how do I make this go reverse? That's what that negative sign is for. So instead of being a positive speed, it's going to be a negative speed, and it is at full speed. So negative 127, that's making the motor go in reverse speed at full speed. And then I'm going to do the same thing for my right motor, because that only started the left one. So I'm going to replace this with right, negative 127. And how long was that going for? Because every time I'm starting the motor, I have to indicate how long it is. So in the simple step here, we wrote down that we have it going in reverse 5 seconds. So I need to do that for 5 seconds. I go over here to see wait, how long? I'm going to take that code over here and replace the blue letters, which is going to be 5. And so the last step then is simply stopping the motor. So I take my code from over here, copy it, and which motor am I stopping? I can't just say both. I'm going to say left motor that I'm stopping, and then do the same thing for right motor. So that is one task here where I've taken this entire complex behavior, I broke it down into simple behaviors here, 5 of them, and then from there I broke each one of these down into basic behaviors. So if I were to plug this into the computer and have my test bed going with that, until bump switch, start motor left, start motor right, wait 5 seconds, stop the motors, and then start them up again in reverse speed at full speed, wait 5 seconds, and then stop the motors. So that is one entire task that I just did with you. There are two up above here that you'll have to do. Maybe you did together in class, but then there's a few down below that you have to work through for your homework today.